now we will go more deeply into details about the two energy contracts, Clean for Energy and ECEM, and this will be a 4 hands and 2 voices presentation by Robert and Alberto, the team of the year.
Thank you, Laurent. So, yeah, again, it's going to be a 2-voice. So I think you quickly have to come up on stage. It's going to be a 2-voice presentation, giving you most of, not in very detail, because there will be details later. I think it's this one, yeah. And then Control L. Yeah. So we've been working for 2 years now, trying to produce a number of information, trying to communicate. It's a lot of communication. It's a lot of explanation, but the way it is explained is very important about how we can use climate information in the energy sector. So we were 2 consortia, 2 contracts giving a proof of concept of climate service for the energy sector. So right from the beginning, I think we kind of started to work together and see what do we do together and what we don't do together. So that's so let me first show you what the contracts and the institutions participating to these contracts have been in both cases, and then I will try to explain the strategies, the common strategy we have put in place, not to double things, but to make things more valuable. So in the case of Clean for Energy, and I will give the floor later to Alberto for ECEM, the principle was to base our work on the experience of our colleagues, mostly from the weather services, but also climate services and also universities, in collaborating with the industry on the kind of one-to-one basis, and then to build upon this knowledge across Europe with different themes to build indicators that would apply to any kind of country or situation. So that is why we have formally seven contractors or subcontractors in Clean for Energy. So we, CEA and CNRS, lead the contract, but we have been working with the Met Office, with SMHI and FMI, who are the weather services in the UK, Sweden and Finland, as well as Météo France in France, and the Barcelona Supercomputing Center in Spain, and the Gerix Climate Service Center in Germany. And each of our partners has been working with different stakeholders in their countries or in neighboring countries on a specific theme. I won't go into details, but we have approximately 10 industry. They are not partners, they are not funded by the project, but they are willing to contribute to build this service or this proof of concept. We have a website which is shown in the bottom, and what we have tried to do is to do some database of indicators, climate data. We have a database. We have informations like fact sheets or documentation, and we have some different forms of visualization in a demonstrator as well. So I leave the floor to Alberto for ECEM.
Okay, thanks. So we wanted to show the overarching approach of the two projects here. So I'd like to take you back about 3 years ago when we were trying to plan these projects, when we were still calling them projects. And that's because we didn't have a good idea of what the Copernicus, the C3S was aiming at. In fact, we probably put too much research in for the taste of C3S in our project, but we envisaged this as a way to gather as much information as possible in terms of climate and energy, and relate the two really very closely at the pan-European level without any specific application in mind, but as a way to generate that knowledge and experience that would engage with the energy sector as a whole. And so we've had a very strong program of stakeholder engagement, which is the work package 1 and, at the side there, underpinning all the activities that we've done. And as you can see, that's led to some products that are, in most cases, at a pan-European level. And we'll discuss that in more detail later. But at this stage, I just want to acknowledge the contributions from all the partners. The project was led by UEA, but strong contributions from EDF, University of Reading, Met Office, Armeens, and ENEA. And as you can see, the overall goal was here the integration of energy and climate for an assessment of energy mixes for Europe. And we'll tell you more what we mean by that in the next lecture. Thanks.
So, yeah. So the common strategy, so when we started to discuss together at your first stakeholder meeting, by the way, we were asking whether we should work together or not. So actually there was two concepts that we wanted to have it as a central for the collaboration or non-collaboration. First of all is to ensure the diversity of approaches. That was also asked to us, not to copy ourselves. So we had to guarantee the diversity of our approaches, of questions, and way of presenting things, etc. But at the same time, we have a major problem, which is that climate information is already extremely diverse and extremely confusing sometimes. So we didn't want to add confusion on the top of this already existing confusion, and we decided to use more or less the same data. So that's we have a common trunk, which is sharing data, working, exchanging data sets, and in some time it's even difficult to know who owns which part of the data set in the construction of the climate data. But as soon as we are discussing presentation, communication, stakeholder engagement, we wanted to do it really separately, and I think that's what we've done so far. So there's a diverging arrows. So that is why maybe it may seem confusing. We have two projects and we are presenting different products and presentations, but they are all coming from the same data, and that was our strategy. So what is at the core of our products? The data. So the data start from the climate data, and they are transformed into other data sets which can be usable for the energy sector. So if one takes, for instance, on the left-hand side, the historical climate data or the historical energy data, we start from observations, reanalysis. So the reanalysis, for those who don't know what reanalysis are, it's a combination of model prediction and observations, which is supposed to be the best fit of the reality, using all the information available. And sometimes these reanalyses are not bias-free. We'll see some examples. And we have to, because the models are not perfect, the observations themselves are not perfect, so we have to use different sets of observations also to try to bias correct the reanalysis themselves. So in the case of surface downwelling radiation, or how do you call that, GHI, or global horizontal irradiance, we use the reanalysis, but they are somehow biased, and some satellite data were used to correct these biases. So this will be maybe explained later. But then, so that's in order to produce a data set which is of the best quality for its purpose, that is the use for the industry. So that's the climate variable, the irradiance. Now, if we want to transform it into a variable that is useful for the energy, and that could be an indicator for instance, the solar photovoltaic power, then we have to bring in not only climate data, but data coming from the energy themselves. That is to say, for instance, all the installation of solar panels, their characteristics, their so there is some data from a different nature that is coming in, and that is the same for climate projections. But for climate projections, there is another bias coming in, which is the bias of the climate models themselves. The climate models are usually they are not forecast, like starting from observations and going for the next day or the next 3 days or the next months. They are started, these are self-running models which have been started in the 19th century. So we cannot expect the climate models to match the events individually. But what we expect from the climate models is to have a good climatology, a good average, a good distribution of events, etc., so they can be used to estimate risks, for instance. But they have biases also, so we have to use these reanalysis from the historical to correct the biases of the climate models. So this is a bit technical, but this is what has taken a lot of time in the course of the projects. So going quickly to the historical data, what we used is ERA interim. The reanalysis, also some bias correction of the reanalysis, which is called WFDEI, which is a data set which has been built in the WATCH framework. This is called the WATCH Forcing Data ERA interim. And we have also used observations, solar stations, EOPS, HAD ISD, which are station data, weather station data, and also some data from satellites like HelioClem. Then to bias adjust the reanalysis, so there's a long list of technical things, but what actually ECEM has done was to assume a distribution. For instance, it's very classical to assume that the wind speed distribution is coming from a Weibull distribution, or Weibull, I don't know how to say, for wind speed. So if we assume this, if you're a statistician or if you're not, it's just a distribution which depends on two parameters. Two parameters. And then what we are trying to fit to the observations is these two parameters and the shape of the distribution. So in that case, we correct the parameters of the distribution, taking observations and models on the one hand and correcting it to the observation. So there's been a number of assumptions on the distributions, but basically I think we are going to show things only for the winds. So for instance, in that case, let's focus maybe on the right-hand side. This figure shows stations that have been used. I think this is HAD ISD. and they show the difference in one of the parameters of the variable distribution for the winds at 10 meter, which is the shape parameter. It regulates the more or less the way it goes to the tail, this is the difference between the observations and the reanalysis. And it's interesting to see that there are many stations for which there is a very large difference between the observations and the reanalysis, although the reanalysis take on board some of these observations. Maybe not this one exactly, but anyway. So this is to show that they need to be corrected. One cannot take reanalysis as granted for application. It is very important to assess their biases. Then the comparison has been made between corrected and uncorrected with different data sets. I will not go in big detail. Maybe you want to. I think what's important is to say that we are on a ground, when we want accuracy, we are on a ground where we cannot just trust models, and we cannot, on the other hand, just trust the observations. We have to really understand how these observations were made, where they are. For instance, if they are located near a coast, then we cannot have the model resemble much the observation, because the observation is not, there are strong gradients if we go closer to the coast, and the model is just representative of a big box of 50 kilometers or more. So it's very important to understand that what is the quality and what is behind the data that is provided. So at least in ECEM there was a strong effort in doing this, checking the land, sea masks, etc., etc., and we still see some strong differences between observational data sets. So there has been one data set produced for winds and also for other types of variables. Now, seasonal forecasts. You're the expert, better than myself, so take the floor.
Okay, so this is one of the switches, and we'll just briefly mention the work done on seasonal forecast. Both projects dealt with seasonal forecast in slightly different ways. What we did in ECEM is to use three systems, the ECEM French system, and British UK Met Office system. And we've done an assessment of what the skill under certain measures is for the variables that are relevant for energy, the main variables, and here we have a summary for the climate variables to start with. So we've done it for the climate and also for the energy. For the climate, it's interesting to start to look at what happens there. This is just a correlation measure, so it's one of the skill measures. But you can see that various different variables will have different skills, as you can see. ECEM, for example, here has a lot of red in for temperature, which implies a good high skill, but it's somewhat misleading because this is picking up also the trend. For example, the reason why people are wondering why the other two systems are not as good is also because the period is shorter. So the bottom two have about 20 years of reference, and the top one is 30 years roughly. So that makes a bit of difference when you're looking at trends in temperature. But nonetheless, there is a big trend, and so that's an important message as well. And then you see other reds here and there areas, and let's switch to the next one, which is okay, because this is what summarizes the skill assessment that has been done by the Met Office in this case. And there's a report also available on our ECEM demonstrator to come up soon, and with a lot of information. This is just a summary. With the three measures that have been used, you can look at country by country and variable by variable, and look at where you expect to see some skill. So this is a very interesting table, a bit confusing. I don't know if you can read it all, but look just at areas where there's some yellow and where there's some green. Green is better than yellow. Green, it means that you have 3 scale measures green, so giving you some sort of scale. The yellow is only 1 measure, and the pale green is in between 2. And the countries are listed up here, but I won't go into the detail. You see, what you can see also between the left and right is that on the left you have the summer, which has generally less scale than the right, the winter. So that's something also interesting to look into. We've done, as I said, also in ECEM the assessment for energy-related, well, energy variable. In this case, is the prediction of the PV photovoltaic capacity factor and the scale it has according to the correlation. So you can see that there are some areas, particularly in Eastern Europe, actually, where you have gaps in your map. We do have scales, so we can put the two together and try to see whether we have complementarities. So that's an interesting area to look, this one, in terms of scale of capacity factor. In Clean for Energy, as I said, they did also seasonal forecast assessments. I must say I don't know all the details, but here is one of the plots that has been produced for the wind power capacity factor. What I would like to highlight with this is that you can see that the black is the ensemble mean of the forecast, and the gray dots, the small dots, are the ensemble members. So you don't see them, but I see them. Yeah, it's I'm like Jean-Noël, I have superpowers. And the red are the observations. I mean, we don't want to look at the data. So the summary is what we saw before with the correlation, the other skill measures. But then it's important to look at these graphs. And when we look at these graphs, it's important to look at not so much there are places where there are differences, but it's also where the forecast system is picking up some signal, and that's where it's important to focus. And in fact, there is going to be a project just aside. It's a project that just started under H2020, which I'm leading, and it's about picking up and trying to extract as much information as possible from this seasonal forecast systems. And if you want to know, there is going to be a poster also. And I'll just now switch to climate projections, and since I'm not the expert, I'll leave it to Robert to talk about it.
So, yeah, just to complete, we did indeed a lot of, especially the BSC team has done a lot of estimation of the wind power seasonal forecast skill. So I invite you to go to our demonstrator. Anyway, regional climate projections. So climate projections are projections for the future decades, going far into the end of the 21st century. But when we, of course, started to ask whether what is useful, I think almost nobody answered the end of the century. So we limited ourselves to the middle of the century, for which there's a lot of interest. But also, what was interesting was that also there is a large interest for the current risks. I mean, the current situation on the climatological point of view. And I will show you some examples. Because these risks have changed already from past observations. In a sense, the observations we have, they stop today. And if we take 40 years back in time, they are kind of obsolete now, more or less, because climate has changed. Then the principle here was to use the most recent data sets of climate projections, which were taken from what we call regional climate models. So I have to explain a little bit. How do we do a regional climate model focused on Europe? We first need to have a global climate projection using a global model. So a global model is something that runs for the ocean together with the atmosphere, together with the cryosphere, with the land surfaces, with the carbon cycle, etc., etc. It's an Earth system model that runs, that is started in the past, and that is predicting the climatologies that depend on the evolution of greenhouse gases and aerosols and other types of forcing like volcanic forcing, solar forcing, and the evolution of land surfaces also. So from this global climate model, we can try to zoom in to Europe and have models that are better resolved. Typically, the resolution, at least for the last exercise, which was called CEMIP 5, of global models, the typical resolutions were from 100 kilometers to 300 kilometers. So it could be fine in some cases, but more details are needed in many cases. So the strategy in that case is to have a physical model that runs only on a limited area, but has a much higher resolution. So that's along the chain. We can have then impacts model, for instance, for hydrology. So we all know that these models, these climate models, have biases, have uncertainties. There's also a large amount of variability within the system itself, and there are many difficulties sometimes in interpreting. And the climate modeling community today never gives a statement that is based on one model only, or even two models. Is really risky. So that is why all the models usually do the same exercise, the same with the same forcing, etc. And we try to run several models at the same time and assess the uncertainties based on the spread of the responses. So that's also what has been done. So that's what's been done in the global climate model community and in the regional climate model community. Here in the projects, we used Eurocordex simulations that was based on about 10 to 11, depending on version, models, which are actually couples of global climate models together with regional climate models, sometimes coming, and often actually coming from different teams. One team running the global climate model and the other team running the regional climate model. So just to show you what is, I mean, if we look at the effect of resolution, this is Corsica and the rain. In this model, the rain is largely overestimated, but at least it falls on the mountains, and which is not the case in the 50 kilometers. So that's the interest of resolution. But what this map is not showing is that even if we have better details, we have gross uncertainties on the large scale themselves, because these regional climate models, they don't fix the problems of the global climate models. So the large scale uncertainties remain, actually. So that is to say that these climate models have biases. We know that. We have to make sure that these biases are not too large. And what we try to do is to adjust the distribution of the climatologies of the model to the observations, because when we are to calculate impacts, like for the energy, the water resource, or whatever, agriculture, etc., we often are facing to thresholds, and with a bias in the model, it's not, we give a wrong answer to the impacts. So that's a bit, so it's not really a solution, but that's the best way we can do so far. Of course, the best would be to go back to the source of the uncertainty and correct it. but it's not possible at this time. So this may be possible in 50 years, I don't know, but or in 10 years, if we're optimistic. But at the moment, this is not the case. The models are biased. So we have a bias correction algorithm. I'm not going to go in detail. It's been tailored for several applications. For instance, for precipitation, for which it's very tricky because we have a singular distribution at 0. We have to correct also the frequency of rain and the intensity as well. Anyway, so what we have done essentially in the Clean for Energy was to work a lot on this bias correction and assessing the effect of bias correction and look at different data. For instance, we take the climate model, we bias correct the climate model with using the reanalysis, and then we use a different separate set of observation like HAD ISD or ISD light. In the case of winds, in this case, in the upper left graph, these are stations for winds where wind is measured. Again, the observations are not perfect, but we can compare the observations and the model, which is bias corrected by the reanalysis. And this is what is done on average here on the top right. We see a mean bias of less than, say, 0.5 to 0.6 and a negative bias. It's kind of something we expect because the wind in stations takes into account a number of factors that allows the wind and the turbulence to act and give very large values sometimes, while in the models the winds are representing an area of about 50 kilometers, at least 12 kilometers in this case, of climate projection. So yeah, so we also checked the extremes of the distribution of the wind, extremes in terms of stations, and this is the bottom graph. For instance, we see that in IST light, again, we have a bit more amplitude, especially for the percentile 90 or 95, but the bias-corrected data models are doing quite a good job. Now, what we have tried to do also is to try to, in a sense, simplify the task of the users. In many cases, the users tell us we don't want 11 models, we don't want 20 models, we want. They often say we want one model, the best, but this is never a good solution to take one model. So what we have proposed, and we have done this algorithm in collaboration with EDF, is trying to get a method to extract maybe the 3 or 5 models that are best representing the ensemble. So users can use only 3 models, and I mean, it's much cheaper than using 11, and it may be simpler to interpret. So we are trying to extract these 3 models, and there is a filtering procedure that we have put in place. First of all, identify or exclude outliers, select sub-ensembles based on climate sensitivity. We don't want all the models to give too high warming to be in the upper tail or in the lower tail of the warming. And then select sub-ensembles possibilities based on the response on all variables. So we have metrics for all that, and I'm not going into detail, but just give you an example for the selection of 5 models. It's the GCM plus RCM, so some of you may know these names. These correspond to different global models and regional climate models. So we have a kind of diversity of couples of GCMs and RCM that are best representing the ensemble of 11. But there is also a result for 3 and for 7 or for 2. Anyway, I want to now present a few products beyond the climate data. We have been working with our colleagues from the different institutes on case studies and types of energy questions, wind power generation, and especially the seasonal forecast with BSC, the question of supply generation balance with Météo France, the bioenergy with the FMI, as well as the freezing rain with FMI from the Nordic countries, hydropower with our colleagues from Sweden, and oil and gas offshore assets, and the question of the ocean going to the platforms in wild ways and prevent things that should not happen to these platforms with the UK Met Office. So we have a list of indicators. I'm not going to go through this whole list, but there are, even in each indicator, there are several options sometimes. For instance, in the wind energy, it's not written here, but we have indicators of the wind power capacity factor for different types of turbines, 3 different types of turbines. We have also other indicators in the other cases. What we have done also is try to make all the data sets accessible for free on international database. Actually, it's a distributed network called Earth System Grid Federation, which has standards, international standards, and quality control, quality check. It's a bit constraining, but it's a good way to have the data integrated into this system, which is actually the systems that the climate modelers are using. And now we have even a sub-selection of the indicators which can be available from this facility here. And I just show one of the screens with on the left a list of potential indicators that you may want to select, and then you have the list of data files that appears on the right. So it's a bit technical, but for those who are willing to really work on the data, not just have maps shown on the screen and copy maps, but work on the data, make your own indicators. This is quite interesting. We have other products as well. We have produced other products like a lot of documentations, technical specification, workflow, evaluation of indicators and climate data. Some examples of application with case studies. Very nicely presented fact sheets from our colleagues from Gerix in Germany. So there is which are synthesis actually of the one question, like what to expect about wind in the coming months or in the coming decades. The formatted, yes, they are formatted, and there are short notes for each indicators. We have produced, and thanks to Nada here, a lot of videos, interviews with our stakeholders, infographics, tutorials, etc. User engagement, I think I've said it already. We work by cluster, producer, kind of with user together, and start by concrete case studies, generalize, it's been said. Demonstrator, there will be a specific talk, so I'm not going through it, but just to show you that we have tried to, whoops, yeah, so the idea of the demonstrator was to make the data accessible from a visual presentation. So here in this case, this is the change in the runoff, I think. The change in the runoff in a scenario for the mid-century. So you see that Spain and Mediterranean regions are drying, and northern and central Europe are wettening. So there is a lot of contrast in Europe concerning runoff in the future. So this is presenting the maps in a certain way. It may not be the best way for your purpose, but at least it's been done with some specifications from our colleagues. And so from these maps we can extract time series, we can extract statistics, and we can quickly switch from one indicator to the other, or from one period to the other. So there will be demonstration today and also tomorrow. There will be tables and stations tomorrow afternoon where you can play with it. So it's the case of the demonstrator is really based to have all the spectrum of potential use for users who just want a map of the trend in precipitation or in runoff. You can have a map, or access to the technical data, so there can be access to the technical data as well. So there are different levels of use. Just case studies, a few case studies to finish and give the floor to Alberto. I don't know which time. Yeah. So, yeah, I have 5-10 minutes. 5 minutes. 5 minutes, okay? Yeah, 5, okay. Then electricity generation demand balance. I won't go into details of these case studies because there will be station and tables tomorrow afternoon explaining in detail. The idea was to be able to provide time series at a 3-hourly time scale for every country or for every region, sub-region of every country, for wind power, for demand, and for wind capacity factor, for solar capacity factor, for demand together, and to be able to have scenarios, kind of worst case scenarios maybe for studying risks for the transmission network in particular. So that's for the current situation, historical, current, and future. Yeah, here just a slide about risks of cold spells. This was just to compare the January 1985 case with risk curves with return period, return value. So this is the thermal indicator from Météo France. It's the average temperature over 30 stations. And to show that in 1985, the risk of having a month like January 1985, which was very cold, much colder than this February, was about 50. It's something that occurred every 50 years. While using these climate projections, today this risk is divided by 2. So we often hear in the media that cold spells could be a result of climate change. What all the models say is that it's not the case. Cold spells are becoming less and less frequent, but they are still present even in the future. So, but with a slow rate of decrease. Anyway, we have other cases on bioenergy. So there will be a good poster by our friends from FMI on the conditions for bioenergy production and harvest of forests, which is a bit tricky in the winter, which is a bit tricky not in the winter because in the winter it's frozen, but in other seasons it's very sensitive to the moment where the snow melts. And so we have scenarios for the future. And also for oil and gas, there will be a poster. There will not be presentation tomorrow morning for that, for these 3 cases. So that's why I'm showing them here. Maintenance, commissioning or decommissioning operation of offshore platforms, they take a lot of time. So they need good conditions to operate. And it's nice to have a period where to operate and to have predictions. So I encourage you to see the posters from the Met Office and the tables that will occur tomorrow. Yeah, so that's your turn, Alberto. Oops, am I right?
Yeah. Okay, thank you. Thank you, Robert, for leaving me 10 minutes at the end of your talk. I'm joking. No, it's okay. Just a joke. Okay, so now switching gear to ECEM. So you may wonder also why, I think that was a question for Jean-Noël, you may wonder why C3S decided to fund two energy and 2 water, why not 1? And I hope you see the scale. I mean, for other sectors probably it's the same, but energy and water were regarded as the priority because of the obviously needs from the industry. But you can also see from the work that C4E has done and ECEM have done that there's such an amount of work that is going on in the last 2 years and a bit. I think I'll only scratch the surface with the next 15 minutes, and I know there are other presentations, but I just want to I wanted to emphasize the fact that there is so much more than I'll be able to show here, and I realized that as well when I was I recently finished an interim overview paper of ECEM, and I had to throw out so much material because I had to keep within 20 pages, I think, or whatever it was, 15, 20 pages. Anyway, so let's see what we did. So in this approach, we basically divided the work packages in terms of like kind of logical sequence. You look at the climate variables up there. That was work package 2, and then we do the best we can in terms of calibrating and bias adjusting these variables, which is what Robert described before. And then we convert these variables through a Wien curve and all the other transfer functions that you can find to get variables in the energy space. And although we haven't really treated thermal power directly, we have the elements from the calibrated climate variables to deal with that, but we did a lot of work on demand, hydropower, solar power, and wind power. And then we also produced a lot of documentation that will be discussed by Claire, and Barbara later will show you how the demonstrator works. So again, I will only briefly touch on that. And we then produced all the products that are now mostly are available through the demonstrator, which is the image up here. And one thing that we wanted to do with the demonstrator, I would say the overall approach or the philosophy we used in building this demonstrator, it was trying to get the information as accessible as possible in terms of not going into the grid level. So although we know that we can provide data at a higher resolution, particularly spatial resolution, we didn't want to display that onto the visual demonstrator because we wanted to be able to, for people to be able to play with the demonstrator and have actually the files preloaded, so you don't have to spend time, or the computer doesn't have to spend time to calculate all these things behind the scenes. So what you have there is very fast access, but obviously you have to offset that with access to averages over countries, but also 100 sub-regions within countries, which are called clusters in our case. So that's why you see often country averages or clusters averages in our case, and you get maps or you get time series. So this is one of the examples I wanted to show you, that one thing that you can do, and probably Claire will tell you a bit more, but this is, you know, if you want to see how the solar radiation will change in the future, you can have, can play with this, and you'll see from here changes in the north towards a decline in radiation, and the south increase in radiation. We have produced a number of plots. We played around quite a bit in terms of visual presentation of this information, and we came up with some plots that I think, although they look a bit messy, I think they are really useful because they contain a lot of information. They contain the ensemble members, they contain the mean, they contain the observations, so they contain 2 scenarios, and so on. Again, I think Claire will tell you a bit more about this, but we also have the opportunity to look at our demonstration session tomorrow. Behind this, it's been touched a bit before, but I really want to emphasize the work that's been done here under the leadership of Laurent sorry, just a point, because I know there are 2 Laurents, so I want to, sorry, but obviously without taking anything out of your work, but this case was, in this case was Laurent Dubout, and there's so much work to gather information about just the observations. We were actually quite lucky to start this project at this point in time, because there were parallel activities, like ENSTOI is the European Association for Transmission System Operators, and they started to create this transparency portal, which is now very useful, but it wasn't available 2 or 3 years ago. So we actually started, C3S was very far-sighted and thought that it was a good time to start it now because of the other data coming available from the energy field. But a lot of work has been done also to clean all the data, to make it in a format that it was useful for us, and so on. So it's, we shouldn't underestimate all this work. And if you want to get Laurent started and mention this energy data, and you'll end up at dinner or later. Anyway, so the work that this summarizes, again, a slide from Laurent that summarizes the conversion of the climate variables into energy variables, and here we have demand here through some statistical models. Wind is done both with statistical and physical models, like here, and then solar with physical models, and hydropower with statistical models. This will be explained better tomorrow by Laurent and Matteo for the hydropower. And but again, this although we did this conversion, we should also remember that there are many aspects that we haven't touched, because for example, when you look at the curve that converts wind speed into wind power, normally, as I showed before, it looks very neat. It looks like a simple curve. In reality, if you look at the experimental values, it's a very wide scatter. So, you know, to access and test all the possibilities that you can have to convert one climate variable into energy variable would be a very long process, and it's done by other projects and so on. So I guess the idea is to take some of that, but still you have to implement these conversions, and you can't just take what's in the box and apply it most of the time. Just an assessment of what was done for the wind in this case. So many models have been tested, statistical, physical, using also the corrected value of wind and uncorrected value, but also taking other similar products, in this case from the EU JRC, the green in green, and Ninja, developed by Imperial College Group in red. And I won't go into the detail, I think Laurent will describe it, but it shows that there's actually quite a lot of variability amongst models, and often it's difficult to actually pick up which model is better. So in the end, we chose one, but it's not really the optimal solution. We would again present this information through time series. I was told at the beginning of the project by a team member, actually, who I'm not going to name, that he didn't find the project too inspiring because we were going to deal with time series of countries and here and there. And 2 years later is probably the person most excited about the project. So that just to tell you, the amount of information and the quality and the content of the information is really. I'm quite amazed about what the team has produced. So in terms of time series scenarios, we looked at. We based our work also on another previous project that was led by transmission operators and other energy companies and so on, called E-Highway 2050 scenarios, and they selected some energy scenarios. So what we did was to take those scenarios in terms of energy, which are ultimately based on EU energy scenarios, and we basically superimposed what we found in terms of variability. And so in this case, with the wind for the UK, you can see that depending on which scenario you choose, you get obviously very different results. And so you may say, the scenario is the thing that is really important. It's not so much the variability, but actually, there are some scenarios that overlap here that show where you can see that the interannual variability of due to climate, so the wiggles there are really what is due to climate, is really important. And if you consider also that the scenarios were chosen in such a way that they were very different from each other, then you can imagine that the interannual variability due to climate is really very important when it comes to power produced by wind, but also solar and demand as well. We demonstrated that, and you can find all the data on the demonstrator. So to build this, actually, we took the approach I mentioned before. There was a very intensive plan and work on stakeholder engagement, one workshop every 6 months. This is kind of our last workshop together with C4E, but it's part of our plans of workshops as well. And so we basically engaged with a lot of people to trying to find out from the scratch how we could build this demonstrator. So that is basically the underlying story. We wanted to have iteration with the external stakeholders, knowing that we had obviously a lot of knowledge in the team with EDF and all the other partners who knew a lot and know a lot about the energy scene as well as the climate. But we not only did we do workshops, we had other activities like social media, one-to-one presentations to people who were interested would go, and other people would go and present the project. We had a program of webinars as well. We had, I think, 6 webinars overall, and we're going to have 2 also during March. We did promotional videos that you can watch. It won't show here, but it's quite cute, only 3 minutes. This is just to show you the sequence of workshops. This is what kind of happened in some of the workshops. This is the second workshop. We're trying to brainstorm about what the demonstrator would look like. And I'll show you also in a minute here the kind of sequence that this is Claire's slide. She may show that again, but just go quickly because it's important in this context of engaging with the stakeholders, people that are potential or prospective users of the demonstrator. So what we basically, at this stage of the project, we had a workshop with different aim and different engagement techniques. And we basically kept the demonstrator under cover for about half of the contract, and then after that we started to open up, and so we went into the open and started to play around that, following also the marshmallow approach, which I will explain to you later. I just learned about that, but it's a good way to approach product production. Okay, so we came up with this, as I said, I'll just scratching the surface. I'll give you a link so you can play while I talk. And so if you go there, you'll find this map with all the information here. As I said, Claire and Barbara will tell you more about that. But don't be too attracted by the images, or at least not straight away, because there is a lot of documentation to be read. So you can start with using the demonstrator, and you get introduction, getting started, a lot of information over here. And then you can go over to key messages, which is similar to what Robert was saying also, that it was done on Clean for Energy, about just a two-pager to say to people, you know, what happens if, in terms of temperature over the next 50 years or so, or other variables that are relevant, and so on. And we produced also for each variable that we produced, both climate and energy, we produced a variable fact sheet which looks the same on the front cover, but then behind we describe all the details about the data, how we got the data, how we manipulated it, and how you can get it, and or references and so on. So a lot of work again that has gone into that kind of information, which is key to presenting all the data. As I said, it's important to read a lot of the documentation before really playing with the data, although it's tempting to look at the time series that my friend didn't like at the beginning. But the case studies also is another area that is being developed a lot, and Emma is going to talk about that tomorrow, so I'll just show you an image here. But it's I think we came up with also a nice format here with the 4-page format, and it's very concise. The front cover gives you a summary, like a executive summary of what you're going to see, and then inside we describe what is the energy event that is being tackled, what is the climate related to that energy event, why the two interact with each other, and what we can do with the data from the demonstrator to learn more. That's in essence the logics of them. We also recently, I don't know, Claire wasn't, I didn't get the approval, but I think we are ready to also launch the 2.5-minute survey, because it's 5 questions, so it's 30 seconds per question. Very quick, multiple choice. It's probably even shorter than 2.5 minutes. So if you want to note down the web address, we'll send it around anyway. The presentations will be available, at least this one. And as I said, there is also, shall I try that? No, doesn't work again. And this is the website of the ECEM, which I don't know how long it will last, given that the contracts are going to expire soon. Probably something we didn't explicitly say. I mean, I mentioned a few times, but for people who don't know anything about the duration ECEM and C4E, they are project contracts that have lasted 2.3 years or thereabout, and we are now in our last month of operation. You may be interested, if you want to learn more about this climate services. I mean, this is also weather, but the weather and climate services, several of us in the room have produced a book that is available for free, is open access. I don't know what happened to the image, has shrunk quite a bit. Anyway, it looks different on the Springer website. And if you want to keep up also with all the activities, there are many, but 2 of them are happening in China. One organized with WMO and the Global Framework for Climate Services, and as well as BCC, the Beijing Climate Center, which is the Chinese Climate Center. A training course on climate and energy between May 18 and 20, so coming up soon. And straight after that, we jump into the 5th International Conference Energy Meteorology. So if you like to note these things down, I will stop there and thank you for your attention.
You mentioned all the data that were used for generating all this application. I've got one question on the seasonal forecasts. You looked at the 3 providers, ECMWF, Météo France, and the Met Office. As you know, we are building a multimodal system, and we know it has some value for generic skill scores like ENSO, etc. So what do you think we should do, or specifically to serve the wind energy sector in terms of multimodal seasonal forecasts, if at all?
Okay,
the question is for you.
Yeah, thanks. So I guess it's not just not, that's an interesting point for you, actually. I mean, it's a double-edged sword, but I will mention it kind of anyway, because we need to be realistic. Basically, apart from some countries like Spain, I would say, and a few others, if you go to people who actually use the forecast, you know, you want to know in a month's time, you'll find that there are few realities where that forecast is really useful at the moment, because the reality is that the penetration of wind is not very high in general. And so it's good, it's one thing to talk about climate projections, because you can plan and use it for planning and so on. For operations, it's slightly different, and that's where, you know, it's a very good time to talk about that now, because the penetration is growing, and so we can work together with the industry. But if you ask them to actually use it operationally, it's probably very tough in most cases. So as I said, there are exceptions like Spain, maybe South Australia as well, if you want to look other places. But penetration, we're talking about less than 10% in general. So it's when you go above 10%, you probably go above the noise level, and we can discuss business. And also, sorry, want to since you were asking me a question, I wanted to answer one of your questions. Actually, not a question, a point you made about. And something that I haven't mentioned, I should have mentioned, that we actually have in both projects, and it's part of the contract, to provide indicators. We have key performance indicators, and we do monitor how many people access the websites and demonstrators and so on. Although not hugely high, there is a positive trend and promising trend. Would you agree, Robert? I keep monitoring, and I think it's growing. I mean, you see peaks when there are events and so on. But we also, again, need to keep this in context of where we are. You know, 2 years ago, there was next to nothing. Now we built something that is you know, most would agree that it's a giant leap, and or thereabouts. Particularly C4E, no, sorry, both.
Well, it was not a criticism, but it's really the information we need to have and to digest. And in particular, when we move to operations, and if I understand, we will have some what we call purveyors or consultancies here too. And what will be very interesting to know is how much uptake from the data, how much download of the data is done to create these downstream applications.
Yeah, no, I only mentioned because I think it is important. As you say, it's important, and we recognize that, and we're doing it. So I wanted to mention because we didn't do it before, but it's something that we do as part of the contract.
Yeah, just wanted to add one thing on the. I thought initially your question was on the skill. Was it?
Well, it's the fact that we are generating a multimodal ensemble.
Yes.
So how can it be used, or should it be developed differently to serve the energy sector? Because at the moment, I don't think you are using any multimodal ensemble. You're looking at different ensembles.
Yeah, we are looking at because they are a bit all over the place at the moment, but now it's coming together. So I think, I mean, the experience of climate projections is also very good. We have multimodal ensembles with multi-members, and it's a tricky question because you can have one model which has a global bias and another model with a different global bias as well. So there's effort. But what I want to say is that concerning the skill, of course, you may see the skill is rather poor. I mean, over Europe, we have to admit that. It's much higher in some other regions. I'm thinking in Central America, Southern America, and even in the US, because of El Nino stuff and stuff like that for seasonal forecast. But however, there are a few hopes, maybe, which must be said. First of all, the fact that there is no skill is one information. But it's a global information. Yeah, I mean, if yeah, it's an information. Second, there may be situations, specific situations, when there is skill. That's the hope of the seasonal forecast. Maybe in most situations, in most months, there's no skill, but in some months there is some skill, and this is why we have this ensemble. And if all the ensemble is above 0 with significant numbers, even though we have a global skill which is extremely poor in some specific case, we hope so to have some skill. And third, of course, we expect that the models will improve. So
yes,
having a multi-model will help.
Sorry, I should qualify. Yeah, I answered the question more from an operational perspective than a scientific perspective, because in terms of science, there are going to be projects, a European project, H2020, that will answer that question, and they are already doing that. And yeah, I mean, usually people say, yeah, Europe is not. There are actually some opportunities, windows of opportunity, so it's good to explore. But again, I interpreted your question more from an operational perspective, where you get the forecast ready and go, but not do much research to see how you blend things.
Hello. Just a couple of comments, really. Hello, everyone. And I want just to start from where you left, Alberto, because you were just highlighting the fact that actually in Europe there are some places where, as you have demonstrated in one of your deliverables, there is skill, and that's quite promising. And what you've shown today about Southeastern Europe, Hungary, Bulgaria, and Romania, is quite promising, as is an area where we don't have many contracts, as Jean-Noël have shown. And I think there is a good opportunity, and I just want to highlight the fact that C3S, so the Climate Change Service, will open a series of use cases. So these are relatively short contracts and small in budget, but they are devoted to the development of the downstream segment. So very much looking for business opportunity. And so if you are interested, stay tuned and look at our website.
Thank you, Carlo. I think we are behind schedule, so we will break for now. Anyway, you can ask questions to Alberto, Robert, and any other speakers during the different breaks. And so we will reconvene at 5 o'clock.